Okay, so my stepdad gave me this $100 little air compressor, Campbell Hausfeld. There is not much to see on it. I don't even know if it's listing any specs on it. I haven't really looked at it too close yet. Here we go. 2.5 amp. No, still not much in the way of specs on this thing. So I don't have any, I don't even know what the tank size is, any CFM, none of that stuff. No, I can see it says 2 gallon right there. As far as everything else, I have no clue. It's got a 150 psi gauge on it, 2 150s. But from what I've been told, it simply just doesn't work. So I'll dive in here and see if I can make this thing work again. Okay, the first thing I seen was there's these 4 nuts on the top, but I'm pretty sure it's just molded plastic fake nuts. Yeah. So we got these, I think this is just a big cover that comes off. These 4 hex head bolts down here. We'll get a different tool here. One of the first things I'm going to check is just make sure that I actually have voltage all the way down the cord with one of these. And the first thing you want to do is make sure this is actually working. And I'll show you, get you close up here. You go to your outlet and you just stick it in there and make sure that it's actually making a beep. Now this one actually beeps as soon as you touch that clip, so you know that it's actually got a good set of batteries in it. If you go up there and you hit your clip and it makes no sound, that doesn't necessarily mean there's no voltage there. It might just mean that your battery is dead. So I'll plug this in. I'll check down here and see if I got voltage. So I do have voltage at least going up into here somewhere. Could be a bad switch, who knows? Let's dig in and find out. Okay, so it looks like I need a 5 mil bit for this thing. Bolts. I feel like this is just going to lift up. Let's see our switch up in here, and there's a big fuse right there. Something tells me that one is blown. It sure looks bad. Of course, I've got it unplugged or I wouldn't have my fingers in here. Yeah, so it looks pretty bad. Let's get the multimeter out here and test it. Okay, so I got my multimeter out and I've set it for continuity test, beep. I always want to do that to make sure it's actually working. And test the fuse by touching each end of it. Like so, and I get no beep. Another tip is to make sure that your probes are actually contacting the metal good is not to touch them together, but to touch them onto the same piece of metal. That way you know you should be getting good contact. So I'm quite certain that that fuse is blown. I'm not going to say that this is going to fix it, but it'll sure get me a step closer to making it run. And I'm sure I don't have this fuse on hand. Looks like a 3 amp 250 volt fuse. So I'll get to the store and get another one, and then we'll throw it in there and see what happens. Okay, so I got a new fuse. Pop that in place. I bought more than one, so if the first one blows, we know we need to look elsewhere for the problem. And we'll have more put in. I think I even seen it blow. Oh yeah. She blew all right. I don't know if you can see that. Yep. Okay, so apparently we have a short to ground or something here. And this green wire right here is ground. Put the meter continuity test. Let's see. Looks like we got a black and red wire going into the motor on the back side here. It's kind of hard to tell where they're going on the circuit board though. I know these two right here are power coming in, so there's no shorts in the cord itself. I do have 3 wires on the switch though. It looks like the white one is actually power to the switch. Okay, now I can kind of see the black is down here for the motor. Well, it's just too much draw. Let's see if I can get access to the pump here. The lock washer on there I almost didn't see. Maybe if I can get access to the pump, we can see if it's frozen up. turning smoothly. Well, the lock washer almost missed taking off the circuit board. Okay, so there's a bridge rectifier on here apparently. Okay, I see a... Let's say this is a cap, and there's some really brown action here. If you can see that very well. Say that could be part of our problem. I'll check the rectifier too. It kind of makes me believe that the motor is DC. It's interesting. Unless that's only there for the fan. I don't know, that makes sense. I have to look at the circuit board a little harder over here. We got our motor, red and black here on each side of the rectifier. Yeah. Okay, there we go. It is a .630 volt 104K, so that means it's 100,000. Probably 100,000 microfarad. Since I do a lot of electronics, I happen to have a capacitance meter. I should be able to check that. And if I can zoom out a little bit here. My meter is showing -40 and 0.7 ohms resistance. So I'd say that cap is probably blown. But I'd also like to get it out of there and test it out of circuit. Sometimes that makes a difference. Okay, to get the cap out, you can't just use a soldering iron and heat one leg at a time, but I happen to have one of these. It's a Heiko 808. It's awesome for removing stuff from circuit boards. See how easy that was? Now I can recheck this thing out of circuit. And I actually get 100 nanofarad. So I would say that the cap is fine. It doesn't look bad. It looks like maybe the rectifier blew out. What I'm really curious of is I can see the sticker on the motor says 120 volt AC. So is it really that the only thing DC on here is the cooling fan? So now I want to see if I can get the rectifier out of here. It also does not look like it has blown out in any way. Nothing visible anyway. So that would basically bypass any DC circuitry. So I want to put a new fuse back in again. And remount the circuit board and ground. So the fan won't work, but I don't really care about that right now. Just want to see if it can run. But we might blow another fuse. If you can hear that, that's the cooling fan running. Oh, what the hell? So maybe it really is the bridge rectifier. If you look at it, you see the symbols on it. The squiggly lines are the AC input, and the plus and minus are the DC output. And of course, you put a cap on the DC lines to smooth it out. So most multimeters have a diode test function. Looks like a triangle and a plus sign merged. And a bridge rectifier is basically 4 diodes. Okay, 0.5 there. Nothing there. There's 0.5 there. So I get nothing either way on that, on those legs. That's a bad sign. Ooh, I get a 0 right there. And a 0 the other way. So it's possible that it's shorted out. Go back to continuity test. Should definitely not have continuity between legs. I've got one between the minus sign and a squiggly line. So looks like I'll be searching for a rectifier here to get this thing back going. I've got some numbers here. KBPC1-10. And then really I've got nothing else besides that. So I can either find a a rectifier that looks like that, or I can actually put in 4 regular diodes and it'll do the same thing if I get the right amperage on them. So also going to go back and check and make sure. I didn't hear it, but I was going to make sure that we didn't pop the fuse. Nope, still good. So I really think we can get a new rectifier in there. And if I find a cap, might as well get a cap too, and replace those, and we might have a working air compressor again. Okay, so I was able to find the Bridge Rectifier on Mouser, which is an online components dealer that I use a lot. As you can see, it looks exactly the same here. And it says it's a 1000 volt 3 amp bridge rectifier. And there are none in stock. But since we know all of the specs, we can order a similar part. And it looks like you might even be able to find some on eBay or whatever. Look at that. $3.12. $2 delivery from China. Well, I don't really want to wait for delivery from China. That looks like the same one, although the markings do not really match what's on this, because it says 1-10 on mine. I don't know. Let's see if we can search KB PC 1-10. 0. Get rid of the dash. There's 4 of them. Sort for cheapest. This is the same one we were looking at. All 4 are from China. Let's see if I go just search for the bridge rectifier. Forward continuous current of 3 amp. And stocked. Give us 8 of them. Search for cheapest. Yeah. See, that first one's only a 50 volt. I think the one that we had was 1000 volt. Let's see. Peak reverse. Maximum reverse. RMS. I'd say this 67-cent rectifier would probably work. Add that to my cart and return to this video when the components show up. Okay, so I ended up not ordering from Mouser, mostly because of shipping costs and weight. I found a packet of 20 3 amp diodes, 1000 volts, on eBay for, I don't know, it was like $3 or $4 shipped. And then I guess the main reason really was if I buy that one bridge rectifier from Mouser and I blow it up, I've got to order another one. So I thought, well, if I order a bunch of diodes and just do it in that way. Then if they do blow up, I can, you know, replace them as needed, or like continue to figure out what's going on with this thing. So that's what I did. Give me a few days till they show up, and then we'll get back to this.